Okay. Okay, so this is all about real roots versus complex roots. Okay, real roots versus complex roots. Now, in the first problem, you guys are looking at a graph, okay? But they also give you the function for it. So let's say the function was f of x. Again, this is about like number one. So I'm going to give you an example like it. Let's say negative 2x plus 3x whole to the fourth minus x squared plus 3. Okay, a little bit different, about the same though. And let's just say I'm going to make this up. Comes down here, it bounces off the graph, and it kind of does this little wavy thing, and then again, and then just shoots back through. Okay. All right. So if I'm going to look at the easiest thing to do here is to look at, for the degree of the function, is to look at the function itself, since it's written. And where do I find that here? Where do I find the degree in the function up top?
In the first variable.
Yeah, which one tells us? The 5, or which is what? What is it for any of these problems? Which one? The biggest one, not the first one, the biggest one, because that could be like over here. It might not be in order. So you want to go to the biggest one, so 5. Then it's asking, okay, how many real roots do you have? Well, when you look at the graph, where do you see a real root? How do you know it's real? Right, the x-axis is actually touching the x-axis. So you got a real root there, real root there. What's special about that one? And if it bounces, what do we call one that bounces? A double. So when we say double, it's because it counts as 2 roots. So when I'm adding up how many real roots, I count that as 2. Whereas that one is how many?
3 or 1.
Well, total, right, 3, but that's just 1. So if it crosses through, it's just 1. If it bounces, it counts as 2, gives me a total of 3. The second part is how many complex roots. Well, if I can have 5 total roots possible, because that's the degree and the possible amount of roots answers the same question. They're the same thing. Your degree determines how many roots you can have total. So how many complex roots can we have if there's 3 real roots?
5. 5. 2.
2. Basically, these 2 numbers need to add up to that. Okay. You basically can't go past 5. Okay, that's your limit. That's your total. So if you guys are looking at that, the first part says degree. You got to make sure your real and complex add up to that degree. Okay. Okay, so now let's say, let's just look at the graph this time. Or actually, let's, yeah, we'll do something like that one. Okay, so. And let's say x to the 4 minus x to the 3 minus 2. I don't really know if it looks like this, but I'm just going to guess. All right, so that's negative x to the 4th. Hold on, let me switch over here. There we go. Okay, negative x to the 4th. So the degree here is what? 4. There it is. How many real roots?
2.
How do you know?
Because it's going down, it's just 1.
Okay, remember, real roots are where it touches the x-axis. So how many are over there?
0.
There's none. Right, so that means there's 0 real roots. That leaves us with how many complex roots? 4. So basically, once you find your real roots, whatever's left over, that's how many complex you have. Okay. Now, if you guys are looking at the actual graph on number 2, it's a little hard to kind of look and see how many turns there are. It kind of like dips down, then it kind of like dips down again, but doesn't really turn too much. Sometimes your function will do that, okay? Now, if the turn is really defined and it kind of like goes up and down, you can tell, but sometimes it's not as easy, okay? And that's why we rely on the function itself to figure that out. Okay, let's do another one. Okay, so now let's say, all right, now we don't have the function. Now it's going like, comes through, passes back up, bounces off, goes up, and then shoots back down again. Okay. By the way, is this even or odd? Even. How do we know? Both going down. Is it negative or positive? Negative. It's going down. Are any of these positive? No, they're all ending up going down, right? It doesn't matter what's on the end. All right, so anyways, you don't have to answer that question on here, but just review. Okay, so start with, try to get out of the way of the camera. Degree. What's the degree here? Was it? 5. How do you know? What are you looking at? Terms. All right, 1, 2, 3, 4, which means one more than that. Okay. How many real roots?
3, 4.
Okay, how many there?
1.
1. How many here? 1. How many there?
1, 2.
It bounces. So remember, if it bounces, it counts as 2, which means you have 4 real roots. Okay. Now, here's the dilemma with this one. Complex. Okay, how many complex roots do we have? 1. The issue with that is that complex roots come in pairs. So, because remember, like, so like if you think about a complex root, it'd be a number like this. Like if you're solving an equation, you end up with something like this, 2 plus 3i. But usually it's plus or minus 3i. That's 2 numbers, that's 2 complex roots. You don't ever have a situation where you just have 1. So if there's only 1 spot left, that's not going to work. Okay, so there's actually 0 in this case. So the amount of complex roots has to be even. It could be 2, it could be 4, it could be 6, but it cannot be an odd number of roots. So that means that that's it. There's only 4 in this case. So sometimes, and that's why, if you guys look at the title of this part where it asks for degree, it doesn't say how many roots, it says how many possible roots. So it doesn't mean there's going to be exactly that many roots, but possibly there could be this many. All right, so if you're stuck here in this part with complex and you have an odd, okay, or an odd number left, it won't work. So it must be even. Okay, so you must have an even number of roots for the complex. Yes?
Why is that last one not a root?
Which one?
The one going down, yeah.
Because I'm not paying attention. And I'm making myself smarter than I really am. Okay, so you guys probably noticed that too. I missed one. There's actually 5 roots. Okay, but I'm going to make this work for what I was talking about here in a second. So in this case, that would be 5. Okay, but sorry, I missed that one right there because it does cross through. Now, let me try to make this actually work to where it doesn't do that, right? It comes down, and then loops back up. Okay. So I still have that same amount of turns. So 1, 2, 3, 4. So now it's at 5. How could I get this to do what I want it to do? 1, 2, 3. Don't want it to do that. Oh yeah, I could probably do something like this. Won't work for me. Because if I have a 6, that'll be 2. I guess that wouldn't be the case, yeah, because that wouldn't count as a turn, and the degree would still be that. Okay, so let me just go ahead and do it this way. All right. So let's rewind it a little bit. So what I was trying to say is, yes, this must be even. Okay. So in this case, if I make the graph like that, I've got 1, 2, 3, 4, 5 turns now, which means the degree is what? 6. Okay. And right here, we've got how many real roots total? In this case now? 4. So 4 real roots, which leaves how many complex roots? 2. So the moral of the story is that you will always have an even number of complex roots. Okay. No matter how the graph turns out, you should always have an even number. Okay. There are some cases where it kind of like goes like this, it doesn't do a complete turn, and then you will have a situation where it looks kind of weird. Okay, where maybe like the equation says to the 5th, and you've got 4 here, and there's only like 1 slot left, and yes, you can't say that I've got 1 complex root. So just remember, the moral of the story is you will always have an even number for the complex roots, okay? All right, let's flip over to the other types of problems. Thank you for catching that. All right, so let's see. Okay, so now I'm going to go down to the bottom here. Show you guys how to work those out. Okay, so in the last ones, you don't get a graph. You just have the function. Okay. So let's say I've got x, let's say -2, and then x squared plus 7x plus 10. All right. So the question is possible roots, degree, given roots, and then other roots. Okay. Now, given roots, actually first write down degree. Given roots is pretty much that question is asking about what are the real roots. Same question. All right. Other is going to be your complex because they're not as obvious. Okay. And then in the box, I'm going to want you to find the actual roots. So first we're going to start off with how many possibly there are, and then we're actually going to find them. Okay. So in order to figure out how many roots there are, from here it's easy, but from that, what do we got to do with this first? To figure out how many roots it has. Think about what we just did in the beginning of class. We got to factor that out. Okay, so if I do the x here, I get 10 squared 7. What are those two numbers? 5 and 2, it's just like earlier. So this just repeat that one. Then we have x plus 5 and x plus 2. So what are the roots that come from, actually, before we get to the roots, what is the degree? What do you guys think it is? Well, first of all, how many roots do you get from each of these factors? 3 total. So that's your degree. Okay. So when you factor these out, if you've got three roots, that's your total. Okay, including complex. You would include your complex too. Now, what are the roots here? What's the root from x minus 2?
2.
2. What about 5?
-5.
-5, and what's the last one?
-3.
Okay, so those are all real roots because they're just whole numbers, they're not imaginary, right? So that means we have 3 real roots. How many complex?
0.
0. Well, if the degree was 3 and we have 3 real roots, there's nothing left. Okay, so we just have 0. I don't put anything here because I don't want to write 0. I don't want to say the 0 as a root. So just say and leave that blank. Say there's 0 complex roots, leave it blank. Okay. Now the back page, we get back here, this is where you're going to start dealing with complex roots. Okay, so a lot like that problem we saw earlier, let's say, what was it, 3x plus 5, okay? So I did that one on the board earlier. Pan over. Okay. So, first of all, degree. Okay, we'll just answer real roots and then complex. And then we'll fill in how many real and complex we have. Okay. All right, so let's try to factor that first. Okay, let's just say you're working through it, you try to factor it. 5x squared, 3x, 2 numbers, try to figure out what works, doesn't work, okay? So what's our option then to figure out what the roots are? The formula, okay? So I'll have to set the quadratic formula for that. So -3 plus and minus 3 squared minus 4 times 1 times the c over 2 times 1. Simplify it out. I get 9 squared. Actually, let's just do this on the side. So this would be 9 minus 20, which is -11. So just like talked about earlier, over 2. And then we have 3 plus and minus I square root of 11 over 2. Now, how many roots is that? How many roots do you get from that? Anytime you do the quadratic formula, we're always expecting how many roots? 2. And where does the two roots even come from? What part of this makes it 2?
Plus and minus.
The plus and minus, right? You've got a plus version of this and then a minus version. So that counts as 2. And what kind of root is that?
Imaginary.
Okay, that number is called imaginary. When you put it all together, a real and imaginary, it's called a complex root. Okay, so that's your root. And I don't want you to like try to have to figure out decimals or anything like. You just leave it like that, and then put that as your answer, and that counts as 2. So before you answer that question right here, real and complex and degree, you may have to find the roots first. Okay. Well, what about that, x minus 7? What's the root from that? X equals what here?
Plus 7.
Positive 7, and that is a real or complex? That's a real. Okay, so how many total roots came from this?
2.
2 complex. And then 1 real. So 1, 2, and so the degree is 3. Notice how complex is still even. Okay, it comes in groups of 2. Okay, I'm gonna do one more example. Okay. So now, let's say I've got f of x, plus 3, and then x squared plus 9. All right. So what root, before we answer the questions, actually, let's see if we can find the roots. So what root comes from just x by itself? But just x, what do you get? All right, it's gonna be 1. Sorry, I'm out of the picture. I'll make sure I made it. Okay, so from this, it's not 1 though. Sorry, it's not 1. 0. So that's your first root. Anytime you have just x, that root is 0. Okay, so from positive 3, we get negative 3. X squared plus 9. What's special about that? What do we got to do here? What's that?
They're perfect squares.
They are perfect squares, but what's the problem here? I can't do the shortcut. It's plus. You guys remember what the roots are going to be? They'll be 3i and negative 3i. So just think about it. If that was minus, right, you would do x minus 3, x plus 3, and then you get 3 and minus 3, right? But it goes to plus, it's literally the same thing, except now you got to put an I in it. So now it's 3i minus 3i. The other way to solve that is set it equal to 0. Make it equal to 0, subtract 9, and then what do you do here? Square root both. And then you end up with that same thing. So plus and minus 3i. Okay, so you end up with how many total roots? 4. So the degree is 4. Real roots, how many?
2.
Okay, and then complex?
2.
Also 2. Okay, so 2 reals, 2 imaginary. So if I'm working on the worksheet, then in the real box, I'm putting what numbers?
0 and negative 3.
0 minus 3. And what about complex? Yeah, 3i and negative 3i. Okay. Now the last one, you guys look at that. We'll just talk about that one. The last one down here, if you guys look at the bottom, where it says x squared minus 9, well, that's minus, not plus, right? So that you get what kind of roots from x squared minus 9 down here. And they actually switch over to the camera over here. So we finish up. Okay, so that last one down there, x squared minus 9, is that going to give us a real root or a complex root? Those are going to be real. And how many will there be? 1 or 2? 2. So that'll give us 2 real roots. Okay, now this one, if I try to do the x, 5, x squared, and 4x, are there 2 numbers that multiply to 5 but add up to negative 4? Well, the only numbers are 5 and 1. And to get that to be negative 4, one of them has to be what? Does that work? No, because it has to multiply and be positive 5. So this isn't going to work. So what are we going to have to do with that one also? Okay, you're going to have to do the quadratic formula just like I showed you guys on the board. Oh, you guys can't see it. Okay, but just like I showed you on the board with that last one, you have to do the quadratic formula for that one, okay? And figure out those roots. Now, if you're doing quadratic formula, how many roots are you going to end up with? 2, okay? They could be complex, or they might be real. Okay, if you get a negative square root, you know it's complex. If it's a positive square root, then you know it's real, okay? All right, so that's how you work with those. Hope that was helpful for you guys at home. You guys in class, I want you guys to work on this worksheet right now. If you guys have anything else at home, I'll help you right now. Otherwise, that's it for today. Just remember, do the quiz. Quiz is open today. And this worksheet is not in the packet, just as a reminder. Okay? I'll see you guys tomorrow.
All right, bye. Yeah.